All right, tonight's homework is really, really short, you know. You can probably, if you know what you're doing, you can do this in like 5 to 10 minutes. But then you gotta know what you're doing. So tonight's homework is all about one word. Differentiable. This is a really important word in calculus. Differentiable. If a function is differentiable, what does that mean? Well, basically differentiable means a function has a derivative. And that's what we're studying this chapter, right? Derivatives. Okay, but it means more than that. So I guess the layman's way of saying differentiable means a function is continuous, and we know what that means, right? There's no breaks in it, and it has to be smooth as well. In other words, there's no sharp points in it. So if you look at number 1 in tonight's homework, if I give you a graph, you should be able to tell me if it's differentiable or not. Okay, so I'm going to give you an example from each one of tonight's homework. So it's really easy. So how about something like this? I think we need another one here, 4. And then how about, and then let's say there's a vertical asymptote here, and then, okay, is this function differentiable at x equal 1? In fact, let's put a point right here. Is this function differentiable when x equals 1? Well, look at it. Is it continuous and smooth? Well, it's not even continuous, right? Because there's a break in it. Anytime there's a break in it, it's not continuous. So, no, not differentiable. Maybe we should put not differentiable here. What about a 2? Right here. Is it continuous? Is it smooth? Like no sharp point? Yeah, and you know how you can tell that it's smooth? The left-hand slope and the right-hand slope are the same. Because if the left-hand slope and the right-hand slope are different, you would end up with a sharp point, right? So yes, it is differentiable here. What about at 3? Is it differentiable at x equals 3? No. Why? Well, it's continuous, but it's not smooth. It has to be both. So because of this sharp point, it is not smooth, it is not differentiable. And then what about at 4? Is this function differentiable at 4? No, because it's not continuous. There's a vertical asymptote there, right? So once the function is not continuous, it cannot be differentiable, right? So that's what number is. You just have to tell me at what values of x is the function not differentiable. It's easy. You just look for, just ask yourself, is it continuous and smooth? It's either yes or no, right? Okay, number 2, sketch the graph of a function that is continuous but not differentiable at x equal 2. I'm going to change that to x equal 3. Okay, this will probably be on the next quiz. Can you sketch a function that is continuous but not differentiable at x equal 3? There's only one way you can do it. There has to be a sharp point there, right? There you go. So you just have to do it at x equal 2. Come on. Okay, number 3. Use your graphing calculator to graph the derivative of the function. And then we're going to guess what the derivative is by looking at that function. So we can tell our calculator, graph the derivative of something. So in your calculator, okay, don't worry, I'm going to bring it up on the screen there. So we're going to tell, in fact, you know what? I'll do problem 3a for you, and then you can do b, c, and d, okay? So if f of x is equal to sine x, you're going to tell your calculator, graph the derivative of this, and you're going to look at the graph and guess. So this is what you have to tell the calculator to do. Graph the derivative of sine x. Remember I showed you this thing on the lesson? With respect to x. See, if you put an, oh, sorry, I have to put x equal x, yeah? Was there a parentheses there? I forget. Anyway, if we put a number over here, it will calculate the slope of the tangent line at that point. But we want our calculator to graph every point. So instead of putting a number there, you just put x. And then your calculator will graph the derivative of the whole function. So let me show you on the screen here. Oh, does that mean I have to move the camera? So people can see? Oh, I don't know if you can see. Oh, okay, I'll point it over there anyway. Okay, here's the calculator. Put it in the middle. Can we make it bigger? Let's see. Okay. So, graph. Okay, so how do I get the derivative? You go to the template, right? Here's the template button. And which one is the derivative? This one right here, yeah? Fourth from the left. So we're going to graph the derivative of sine x. Where's the x? And then on the bottom, instead of putting x equals a number, you put x equals x. Right arrow, and then enter. So now this thing will graph the derivative of sine x. So now we press plot, and it looks like a trig function. Yeah, but see, this screen isn't great. So like when you're graphing trig functions, you know how normally we graph from negative 2 pi to 2 pi? So why don't we change that then? So go to Shift, Plot, Setup. Okay, what is negative 2 pi? Negative 6.28, right? Because pi is 3.14, right? And then 2 pi would be 6.28, because we're in radian mode. And the y-axis, negative 2 to 2 would be fine, I think. Negative 2 to 2. Okay, on the x-axis, we probably want to put a hash mark every pi over 2. What is pi over 2? 3.14 divided by 2, 1.57? 1.57. And on the y-axis, every 1 unit should be fine. Okay, now plot. Woo! Hey, that's pretty nice. Now look at that graph. Does that look like a trig function we know? Yeah, what does that look like? Cosine x, that's right. So what we just kind of discovered here, we didn't actually prove it, but we proved, well, we didn't prove, we kind of showed. Did we talk about the symbols for the derivative?
I think so.
Huh?
I think so.
Yeah, we did, yeah. Anyway, that's the symbol for the derivative, yeah? The derivative is cosine x. So that's what you do. You graph the derivative of whatever that's there, and then you look at it, and then you just guess. It should be something familiar. I'm not going to give you something wacky. Like if you're in BC, I'll give you something really wacky. We're AB, so it's going to be easy. So all you have to do on tonight's homework is just change that thing right there. In fact, keep it on your calculator and just keep changing it. Keep it there for the quiz too. Why am I giving you secrets? Students, they don't really discover that till later. All right, so that's easy enough. Guaranteed that'll be on the next quiz too. Okay, number 4. What if I give you a piecewise function? This is where you have to give reasons. Just like on today's quiz, yeah? So let's erase this. F of x is equal to, okay, let me think. I don't want to make it the same as tonight's homework. 3x minus 1 when x is less than 2. And then, okay, I got to think here. 5. So 7 minus x when x is greater than or equal to 2. Okay, now these are exactly the kinds of questions you're going to get on the AP exam. is this function continuous at x equal 1? That was on today's quiz, right? Is this function continuous at x equal 2?
Yeah.
Is f continuous? Explain. Well, how do you tell? If you plug 2 into here and 2 into there, you get the same number. Yeah, you plug 2 in here, you get 5. You plug 2 in there, you get 5. So the answer is yes, it's continuous. Because if these two numbers were different, then they wouldn't meet, and therefore it's not continuous, right? But now you gotta explain. What do you have to say? You guys just did it on the quiz. Because the limit of this function as x approaches 2 equals f of 2, and they're both equal to 5. Did you guys say that on today's quiz? Easy money right there. Okay, but the second question, at x equal 2, is f differentiable? That's the word that we need to know. And then explain. Now, what does differentiable mean again? Continuous and smooth. Well, we already know it's continuous. Is it smooth though? Well, how do you know? Well, one way is you could draw the graph if you want. Here, you want to draw the graph? So here's 2. If you plug 2 into both of them, you're going to get 5, so it's here. But the first one has a slope of 3, so it's going to look like that. And then this one has a slope of -1, it's going to look like that. So you can see that there is a sharp point there, right? So the answer is no. There's a sharp point there. But then that's not good enough. The reason that you have to give is because the left-hand slope is not equal to the right-hand slope. And what is the left-hand slope? 3. And the right-hand slope is -1. 3 is not equal to -1. That's all you gotta say. Because that's the only way a graph will be smooth. Think about it. I showed you this before. If a graph is gonna be smooth, the left-hand slope and the right-hand slope have to be the same. If they are not the same, that means there's gonna be a sharp point there. So you just gotta learn, this is exactly what you gotta say. See, on the pre-response AP exam, 1 point, and then this is the other point. 1 point, and then this is the other point. You don't want to just get 2 out of 4, right? No, we want to get 4 out of 4. And then the last question, this is on the multiple choice every single year. Okay, let me do a similar problem for you. F of x equal, what does that say, x cubed? I'll change it to x squared. X is less than 3, or equal to, it doesn't matter. And then what do we do? X plus b when x is greater than 3. Find the values of a and b so that f is differentiable. Okay, what does differentiable mean again? Continuous and smooth. So what will make this continuous? In fact, you did that on today's quiz, right? What has to happen if a function is continuous? If you plug 3 in here and 3 in there, you gotta get the same number. So what happens when you plug in 3? 9. 3a plus b. Okay, that's to make the function continuous, but how do you make it smooth? The left-hand slope and the right-hand slope gotta be equal. And how do you tell what slope is? What tells you the slope? What are we doing this chapter? What tells you the slope? The derivative. Okay. What is the derivative of this? Actually, we've done this on a previous worksheet already, yeah? You guys remember? Oh boy. Okay. Okay, so if you forget, then what? Then you gotta, okay, if you cannot remember what you did, then we gotta go and do all that limit. Okay, so how do you compute the derivative of that? Limit h approaches 0. Remember? Wait, did we cover this already?
Yes.
We did, right? F of x plus h minus f of x all over h. That's what you gotta do. Okay, well, let's do it then, because we don't remember. Okay, plug x plus h into here, so you get x plus h squared minus f of x, which is x squared, all over h. Now is it coming back? No, keep going, Mr. Boyd. Okay, it's 0 over 0, simplify. Personally, I just rather remember. Can I cancel out the h? Yeah, if I factor it out on the top. What is 2x plus h all over h. The h is canceled out. Now can I plug in 0 for x, 0 for h and get something? Yeah, you get 2x. That's the derivative. Now do you remember? Oh, now you remember, but we did all the work already.
Yes.
Okay, so what is the slope when x is 3? What happens when I plug in 3 there? You get 6. Okay, so we know the left-hand slope is going to be 6. Okay? Now, what about the derivative of this? Do I have to go through all of this? No, because this is a line. The derivative tells you the slope of the graph, but the line only has one slope. What is the slope of this? Yeah, that right there, yeah, A. It's A. All right, so if I want this graph to be smooth, the left-hand slope and the right-hand slope gotta be equal. So if I plug in 3 for x here and 3 for x there, but there's no x here, you gotta get the same slope. So what happens if I plug in 3 there? You get 6, and that has to equal A. Can you solve these equations? Yeah. I think so. So obviously A is 6. What happens when I plug in 6 here? 9 is equal to 18 plus B, so therefore B gotta equal negative 9, and that's how you do it. So again, last time, if the graph is gonna be smooth, the left-hand slope and the right-hand slope gotta be equal. Because if they're not equal, there's a sharp point. Okay, isn't this pretty easy? So yeah, you can see this. You can do this in 5 minutes. Okay, any questions on this? We are done yet. Wait, I want to see what Friday's lesson is. What was last night? Oh, last night was the definition of the derivative, yeah?
Yeah.
Oh, okay, so next time, we're gonna learn shortcuts for computing the derivative. In other words, you're just gonna look at something, and we have rules to figure out the derivative. But you gotta wait till next time.